Welcome back. Today we will discuss about the problems in electromagnetic fields on capacitors. Coming back to the last week where we have discussed about the capacitors, we have seen that for a parallel plate capacitor, the formula is C is equal to epsilon naught epsilon R A by T. We will try to utilize that formula today to solve different types of problems. Okay, so the very first problem is determine the capacitance of each of the capacitors in figure shown below. In this case, it is shown at descent. This has been taken from the Kannaba Blasia's textbook, Gangadhar. So consider for the first medium related permittivity is 4, for the second medium it is 6. The total separation is 5 mm and S is equal to 30 square centimeters. So this is one configuration, this is another configuration. I will draw it individually and we will try to sort out the values of capacitances. Now, first of all, let us take this particular, this is medium number 1 and this is medium number 2. Okay, and the total separation is 5 mm, which is equally divided into 2.5 and 2.5. And the area of cross section, it is 30 square centimeters. Okay, now if you carefully see, it indicates that we will separate it in a simple fashion, that this is one medium and I'll take just a simple separation, that this is another medium, right? This is of medium 1 and this is medium 2. Just I have represented in this fashion, medium 1 and medium 2, right? Now what you can see, these capacitances, let us suppose of the capacitance of C1 and C2, these are just in series connection. So for a series connection, what is C equivalent? It is C1 C2 by C1 plus C2, right? So first of all, we will try to determine what is C1 and next we will determine what is C2 and then we will try to solve this problem. So it indicates that C1, we need to compute C1 and C2. So in this one, if you carefully see, it is a parallel plate capacitor, isn't it? So we know for a parallel plate capacitor, C is equal to epsilon naught epsilon R A by T. In this case, for C1, it is 8.85 into 10 to the power of minus 12 into epsilon R1. It is for the first medium, it is 4. And separation, it is 30 square centimeters, right? So which means 13 to 10 to the power of minus 4 by the separation, it is only 2.5 centimeters. So 2.5 into 10 to the power of minus 2. So this is the value for C, isn't it? And for C2, it is 8.85 into 10 to the power of minus 12 into the medium. Now the relative permittivity is 6 into 13 to 10 to the power of minus 4 by 2.5 into 10 to the power of minus, so it is millimeter, right? So I think it is 3. So these are the values. Now let me calculate these values once. This is 8.85 into 4 into 30 divided by 2.5 is equal to, it is, in the first case it is 42.48 picofarads and in the second case it is 63.72 picofarad. Now what is the C equivalent for me? It is C1 C2 by C1 plus C2. So it is 42.48 into 63.72 by 42.48 plus 63.72, isn't it? it is 25.48 picofarad. So this is the way how we will be determining the capacitance. Now, if we move on to the second configuration states that the medium is divided in this fashion. This is the medium, and this is another medium. So this is medium C1 and C2. So if I draw this one, it will be just like okay. So now if you can see, it is just like having two capacitors in parallel. So you will get C1 plus C2. Now for the C1, it is epsilon naught epsilon r a by d 8.85 into 10 to the power of minus 12 into 4. Now if you see the total area of cross section of 30 square centimeters, now it is divided into 15 and 15. Whereas the separation, it remains the same for both capacitors, right? So if I substitute this, what I'll get 4 into 15 into 10 to the power of minus 4 by 5 into 10 to the power of minus 3. So what I'll be getting here? So 8.85 into 4 into 15 divided by 5. So it is 10.62 microfarad. Similarly for C2, it is, if I do the same, what I'll be getting, so 8.85 into 10 to the power of minus 12 into 6 into 15 into 10 to the power of minus 4 by 5 into 10 to the power of minus 3. So I'll be getting 15.93 microfarad. So my C equivalent is C1 plus C2. It is adding of these two. What I'll be getting 26.55 microfarad. So this is the way how we determine C equivalent for the two cases.